Okay, so today, the functions. Functions that we are going to learn today is how to define function, how to invoke them. Okay, so definition of a function that we need to start from, and invocation, that way we can use it, right? But we have used so far quite a few functions. For example, print. Print is a function. We didn't define it, but we can use it, right? So there are massive number of functions available, many of them already built in, and also additionally, the functions that we can define for our own purpose. So either way will work. Okay, so we're going to do what we will do, how to define function, number one. Number two, how to invoke the functions. Number three, that will come to next week. If it is an object orientation, assuming that you know, but without knowing from the basic of object orientation, we can still use it, right? We have used it. For example, format, dot format, and then dot something, dot split, dot, some other things. So that's what we will do. So a little bit of the built-in functions that was defined and associated with a class that is another the container that we define in an object orientation. More formally next week, but today we will taste it a little bit when we are thinking of functions. So there are two types of functions, built-in and user-defined functions. User-defined functions. Built-in functions, that's a standalone built-in functions. For example, print, input, int, so on and so forth. Some of them we looked at many times. Print, input, that we want to make a prompt statement to user and get the response from the user, then we can use int. If there is something that we need to convert into integer, then we can use int. And built-in, those are the built-in functions, standalone functions. You can stand alone, right? Some other functions, we call that method as opposed to function. They are very similar, but if function is defined within a class, within, according to object-oriented paradigm, then we call them method. For example, str, the format. Format goes with the dot notation. And then it should be called from an object. So we have object ID. This is object ID dot format. Format, this function is not running alone, like print. It goes with some of the object ID, some of the string, right? For example, split. If you have multiple, if you have a data in a tuple format, then if you want to split it, then you can split it, and then strip. So this is a built-in functions, and then there is a user-defined functions. So we will do this a lot today, right? Most of the cases that we will do this. Some of the functions, if we assume a class, therefore object, then we call that method. For the functions, two things that we have to do. We have to define and invoke. If it is already defined, then we don't need to do this, right? All of these that we looked at so far, we don't need to worry about. Simply use it. What things to be worried is we have to know how it was defined. Some of the signatures that we need to follow, right? If some functions takes as many parameters as we can, then we can send as many parameters as we define. So number of parameters and type of parameters and those things needs to be followed when we invoke it. So we need to know how it was defined. Not in detail. We don't need to worry about how it is implemented, but we need to know how it is to be used, because it is defined that way. So invoke. For the built-in functions, we know. For the method you define, then invoke it, you define it. So you first defining functions. Before we do defining functions, we need to understand what is functions, right? Function takes input into a parameter so that that parameter goes into that functions. So format of the function is we start with the def, def, and the function name. And if you want to implement that, then we need to put the colon that is the starting of the implementation block of that functions. And it may return output, may or may not. So, for example, functions, it takes A and B, two parameters. Then we need to say, we need to get the values of A and B and ready. Get those two values ready. And then this guy do some of the implementation and then finally return. Then that goes to here. That is a return. And A and B goes to this A, and B goes to that B. That is the way. So why we need to define functions? First of all, by having the definition of functions, we may see clearly that is a block of a code, right? A small segment of the code. So clearly we see it's more readable. Not only that, that is not major reason that we need to define functions. Major reason is this. Once we define once, then we can invoke many times as we can, right? So taking two values, we will return C. Take A and B, we will return C. Then this is one invocation, and another invocation, another invocation, and another invocation, as many times as you can. So we don't need to define this at every time that we need it. We define that once, and then we invoke as many times as we can. So in functions, in programming, we can start with the mathematics. For example, this is a mathematical forms, right? 3 squared plus 2 times 3 minus 5. And we can think of a similar pattern, 2 to the power 2, 2 times 2 minus 5. The other one is negative 2 squared plus 2 times negative 2 and minus 5. Let's say this is a multiple of those things. We want to invoke so many functions, but those are very similar. Then we can think, oh, by the way, this is a function formula, and we call, if this is f of x, then f of 3, therefore it'll be this one, right? So knowing this, we can invoke this. So define this definition of function, we can invoke this as many times as we can, right? The way that we can call, so that we get the computation result for this, if these are in our mind, then we can, because we have this function already defined, we simply call it. First time f over 3, f over 2, f over negative 2. Very nice, right? Simply we invoke that. Therefore, we could have this kind of instances of the similar formula. So we know that in mathematics, so that we can see that in function, if we have this, okay, and this is a function invocation, so invoke this, then 3 goes into x, and x applied to every of those, and return, then that is our function invocation. So functions or method. As we define function, then we know signature, which is input, arguments, and outputs. More precisely, it is input parameters and output. In mathematics, I think they call it arguments, but in the coding, computer science, as it is defined, we call that parameters. The way that we call the same ones, but we name differently. You can use it interchangeably. So no big deal for that, right? In function, you first define the signature, how many parameters that we want to receive, and what will be returned. No return, fine. You want to return 1 value, 2 value, 3 values, fine, right? Body, so depending upon that, you need to implement. That's the way that you can define. Once a function is available, then you can invoke it. Invocation, then we need to know, because this function needs n number of arguments, then we need to prepare n number of input arguments, the values to be passed to the function definitions. Then this function compute those values according to implementation, according to the business logic, and finally get the output, and this output will be returned back to the caller side. Okay, so this is a called side. This is a caller side. Caller and called. Invocations. Call the function exactly as it is defined. This is the key things. Exactly as it is defined. We don't need to worry about all details, implementation details. We simply need to know how it is. We simply need to know how it is invoked, which means we simply know the signature of the functions. Call the functions using exact name and arguments. Function calls. For example, convert the Fahrenheit temperature to Celsius. Then we can say f of x. This is the formula, right? So given Fahrenheit x, whatever the result of this computation, that is Celsius. Okay, so we give x, then This is not x. This is f. This should be x, right? X minus 32 times 50 divided by 90, then it'll return the Celsius C. F, I believe this is a Fahrenheit F instead of that. See? So define function which takes x and return whatever the result to C, right? So coding, you can say enter temperature in Fahrenheit. So if we want to practice it, we can practice it. I want you to bring up PYNB notebook, okay, Jupyter notebook, and then codings here. Then I can say U input equals input, and then I can say enter in Fahrenheit. And because this is, as I said, the input, there's a function. It takes the data from user, more precisely from the keyboard, in our case. Not necessarily from keyboard, it could be from the internet or it could be from anywhere, right? But in this case, from the keyboard, and the type of data that we can get, which is U input, that is a string type. So we need to change that to integer, right? So we can do int imp or int temp equals int that input, right? So if we want to practice it, then we can run this. So if we put here, for example, what is the degree today? So what is, I think currently maybe 65. It's not yet 65. So that is a 65. If you want to show that in a type, then you can say type in temp. So I may be able to show the type. Let's say 56. So the number 56 is that I got that, but the class is int, right? If I done that, for example, rather than this input, I simply as is, and then run it. And then if I say 56, then that is a string int. I didn't yet convert it to integer, right? So I need to convert that to integer. As you see here, then we already used the function. This is a function, standalone functions, right? This is a function built-in but standalone. Type built-in and standalone. Print, that is standalone. Built-in functions. The funny thing here, we learned that today anyway. This function int it takes one parameter, right? Type takes one parameter. But print, it's okay. It could be one parameter. It could be two. It could be three. It is very flexibly defined. How come it is possible? So we'll learn that, right? This is a little bit of the motivations that we can do. And after that, okay, then we need to convert that. So I want to make this, say this is Fahrenheit temperature, F temp, to make more clear, right? Rather than in Fahrenheit temp, and this is a Fahrenheit. I can get Celsius temp based upon given that Fahrenheit temp, subtract 32 and multiply by 5 and divide by 9, and then I can temperature in C, Celsius, for F temp. In okay. So I want to get more realistically, what is the temperature right now? I think that right now 62 to my cell phone. Cell phone doesn't. Cell phone has a temperature measurement sensor in it, but it is not measure the temperature of outside. It measures the temperature of inside the devices. So if it heats up, then cell phones, smartphones may be automatically turned off, either very hot or very cold. But it doesn't give me the real temperature, the external. But I got this number from the forecast. Okay, so I entered the 62. 62 is 16 degree in Celsius, which is that is for the 62 in Fahrenheit. This is a number, right? If you want to make a, for example, if you want to make a format, like in Celsius for this is interruption. In Fahrenheit, and I want to make everything in one string, and then I use format. Format is a function that can call based upon, that is called from the string. String is this is a specific string, so it is nothing but an object of string class. And the format, then we can fill in the first one, that is for C temp, and second one that is for F temp. And if we want to make this, because we have so many of those decimal points, so that we can make point to F. So I want to cut 2 decimal points, or maybe 3, whichever that you like. And if you run this, and now, what was the temperature previously? I forgot. 62. So if you put 62, then 16.67. So this is format. We want to take it in this the format definition. If it is floating points, then I want to make a 3 decimal points, whatever the integer part, okay, and after the colon. This is something that you have 0 and something that you have 1. That's fine. But this is I don't need to say that, right? So this is the thing that we did here. Okay. Any question about this codings? This is simple codings. We didn't make any the function yet, right? If we want to make this as a function, then we need to do like this. So I can say I would say defining a function then we need to do DEF, and I can say Fahrenheit to Celsius. That is the function that I can get the Fahrenheit, and then I will do here return Fahrenheit minus 32 times 5 divided by 9. This is my function definition, right? Right, this guy. Okay. So, thing is this. Once you define this, you can call it as many times as you can, right? You can call, I want to copy this, and here, I would say, instead of this, so I can do here F equals 62. You don't need to say F, Fahrenheit, Farren, and you can say this is a Farren. Farren 62, and there is a Farren, and they give that Farren to the function so that we can say F2C and then Farren. I want to expand this a little bit. I will look at this. This string format is the same as before, right? In the format, I want to enter the Celsius number that you can get from the invocation of this function. The way that you can invoke this is a function name. So F to C, because this function requires one parameter, which is an integer. So I know this Fahrenheit 62. So I use that number, right? If you do not want to make it anything that you want, right? The way that you say here, if you say F instead of a Fahrenheit, that's fine. So that you send this F to there, right? And then you can say, this is my Fahrenheit number. So if you run this, then you can say 16.6. This is exactly the way that I made it here, right? The beauty of this is if you have so many numbers, then you can say temp list equals, for example, -3 and 0 and 10 degree in Fahrenheit. Sometimes we had the 10 degrees, or sometimes 32 degrees, sometimes 45 degrees, at this time 62 degrees, and today we will go up to 69 degrees, and in summer maybe 99 degrees, those things. Can I get, this is a Celsius Fahrenheit number. So I can say this is Fahrenheit temperature numbers. So define ones, can I use as many times as I can? So I have a list of those Celsius numbers, Fahrenheit numbers, so that I want to get the Celsius numbers. Then we can do for loop, right? For each temperature in Fahrenheit temp list. And then I can do exact the way that I did. This is the same as that one's. I want to change that. Instead of here T, I need to say, oh, this already says T. Okay, it's good. And then we can say, finally, print, and all done. Then we run that. It says, if it is -3 in Fahrenheit, then 19 degree in Celsius. 0 degree in Fahrenheit, 17,778. And 10 degrees, -12. 32 degree is 0 in Celsius, right? 62, 16.667 in Celsius. So those are all the things. So the point here is that we define a formula one time in a function. We can invoke as many times as we can. This is invocation, right? So invoke the function how many times? The number of the elements in this list, that many times that invoked. If we do not define this function, then what happens? We have to do this. Where do we get? Oh, all of a sudden okay. So we have to do this as many times as we have to redo this, right? We have to do this for one number and another and another. We have to make this so often. So yeah, move on. So we looked at that. How does it work in Python? So we define it, calling, and then another thing that we could do for this, the converting the points to letter grade. Okay. So So that's what we had here, somewhere here. I think I entered that too early. Okay, so there's a built-in functions. Invoke at least 3 of the built-in functions that you can do. You can use a print, int, input, whatever you want, right? And then you can also do another function, len. This gives me the length of the elements, the number of elements. It returns the number of elements. If it is a string, as I said, then it treated as a list of characters, right? That's what I explained the last time. If we do this, then it gives me, because it's a string is treated as a list of character. So how many length here? 1, 2, 3, 4, 5, 6. That is let's say, if you want to print that, you need to do this. So call how many there? 1, 2, 3, 4, 5, 6. If you do print len and then say 1, 2, 3, 4, then it gives me how many elements? There were 4 elements, right? So in the case 4, like this is treated as say me just like that. So how many elements there? 1, 2, 3, 4, 5, 6. So there you have that. So how to define a function? Then we need to follow function and function name and parameters, and the implementation and return values. So define a function, count characters. So how can you make a count characters? I made that here. If you give it a sentence, then say you have to the initialize the total number starting from 0, and then you can use the function the split. So given sentence, you split it, the list. Then that gives me list, because split, if you don't put anything, that it splits based upon white space, right? So the words that you can see it. So this is a word list. For each word, so you need to take one word, and then you can use the len function. Then it gives you the word, therefore there is no space, right? Word. Not like the space here, right? This is 2 words. But if you consider one word, each word only, because there is no space, if you see length, then it gives you exact number of characters. So for each word, you can count the characters to add to the total number, so that you can get the finally that once. So if you run this, then hello, this is Dr. Yoon, then how many words? Based upon this white space, this is one word. 1, 2, 3, this is 4 and 5 words. how many characters? Then 1, 2, 3, 4, 5, 6, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So each one of those are the characters. So if you want to see, yeah. So move further. You can practice this grading. Given points, if that point is greater than 93, letter grade A, and 90, you can continue to this. So it'll be like this. This is a function that we made this like this, right? If it's greater than 93, then it is an A. Over 90, then A minus. Remember that in these conditional statements, we first filter anything above 93. Well, actually, we need to put here equal sign 93 or above. In that way, we don't lose anything, right? Same thing here. Greater than or equal to 90, then it depends on 93 included or not included. If you want to include, then you need to put here all the equal sign, not included, or inclusive or not inclusive, like this. And the way that you can invoke, then this is function grading, right? It takes the number. Given number, then I can give you the letter grade. That's what it is. So for example, if you have, before we get that, I want to practice this as, for example, I want to make here code list that is 79, 88, 92, and 82. Exact same number here, but not in a dictionary, but a list. Having this list, I can say point in list. I can call this function, right? It's a grading. So I can do grading into point number, then that'll be the grade, right? So I can do, for example, print using format, and this is the letter grade. So that'll be the second placeholder. First placeholder is the point. So point will convert it to the letter grade. And then one more. So when I run this, point, grading, I have to run this first. Run this, then this function is available in Java space, I mean the Python space, so that I can run it. So 97 turned to C plus, 98, 99, 88 turns to B plus. So we can see it, 79 if it is a C plus. So we come here, 79, 79 If 79 greater than or equal to 93, no. So go to else. Else if 79 is greater than or equal to 90, no. Go down. 79. Is 79 greater than or equal to 85? No. Go down. Is 79 greater than or equal to 80? No. Go down. Is 79 greater than or equal to 75? Yes. So letter grade is C+. That's what we got here, right? So letter grade is C+. What if we have a dictionary? Remember that dictionary? Then we can, last week, I can invoke here, call this, and I can make a for loop, right? Again. So I'm going to copy this back here. Little bit of a massage. I can make this, instead of a list, to the dictionary, and then I can get this student. It'll give you the students, right? This is a student list. And then when I call this, I make this more. And then I can make ons that, which is turned to something. So we have to first to put here a student name. So that is a student. And then student point is not like that, but we can get the student's points for student dict, and by giving the name of that students, so that is a student. And when I call this grading function, we need to put the point that we can get from the dictionary for the student name, student key. So for the key, we can get the value. So that is the case, right? To see here, we have 3 placeholders. So student on's points, which is turned to letter. That's what it is. And then first one is stud, because when we have the for loop for the dictionary, then for that variable is nothing but the key in the dictionary, because the dictionary is key and value pairs. So key will be the variable in this for loop statements. So for any variable that is nothing but the key. So for each key. So for the key, which is a student name, and then if we want to get the values for the students, then we can access the value by the key, right? That is the difference between the dictionary and the list. List, here, we can get the value by index. So if you want to get the 88, then we need to give an index. For example, LST number 1, then that points to this 88. On the other hand, if we are considering a dictionary, since the dictionary is a key and value pair, to get the value, then we need to get the key. If you give me the key, then I can give you the value. That is a dictionary, right? Look at the dictionary in real dictionary, then you see the given the word vocabularies, given a word, then I can give you annotation. I can give you the explanation of that the word. That is what it is, right? So give me a key, then I can give you the values. So I can give the key, that entire here will be the value. So that value goes into this function invocation. This is the value. Entire that goes into that function invocation. Function is grading. Grading expects one parameter, which is a value. That is exactly the value that we want to have here, right? So if we run this, then we can get here. Adam wants 79, which is turned to C plus. Exact same ones, but in different way here. Sam wants 88, which is turned to B plus. Peter earns 92, which is turned to A minus, and so on and so forth. So that you can increase the given one definition here. This is one definition, right? One definition of a function you can use at this time for a list, at this time for a dictionary, where there are n number of elements available. So we can invoke it as many times as we can. Right? I wanted to practice this, by the way that I did, right? With the dictionary one time and with a list at another time. Do it now. And if you have any question, let me know. I will give you 5 minutes. Meanwhile, I want to check you guys. If you are there, then all right. Marcos, are you okay? Uh-oh, not there. Bilal, are you there?
Yes, sir. Everything's good.
Yeah. Please do the way that I ask you to do, okay? So just practice time. Gianni.
Okay, Professor.
Okay,
Yeah.
good. Oh, I was expecting you here with me.
I am here. Oh, I'm here on Zoom.
As you promised. Oh, you
I know.
didn't. Okay. Kunji, are you there?
Yes, sir. Good morning.
Hey, good morning. I saw Capo. You replied. Marcos, are you still there? I think he's tired.
Yeah, I'm here, Professor.
Oh, you are there. Thank you for responding.
Professor, sorry. I have one question.
Mm-hmm.
So I saw the announcement for the midterm, and it says we are allowed to have a cheat sheet, and I
Correct.
have no idea like what is that.
Anything that you do not want to memorize it, but you think you want to cheat it. Any
Okay.
notes that you want to cheat, put that on legally on a one page. So that type of cheating allowed.
All
That's a
right.
cheat
Thank you,
sheet,
Professor.
right?
That's better.
Don't look at any textbooks, anybody's. Yeah, don't look over, but uh, it is allowed for you to look. Anything that you want to cheat, put them on that sheet. That is called the
Thank you,
cheat sheet.
Professor.
I know. I think you mean.
This is good, Professor. Thank you. I appreciate it.
Yeah, when I first heard the cheat sheet, I thought, why is cheat allowed? Yeah, it is allowed. I want to give me reactions. React. If you're done, give me more. It's called what is it? Emotion reaction. Move from two bars like this. Send with the effect. Reaction. Yeah, reaction. Whatever your reaction. If you need help, then this cry. This is cry. If you're happy, then you can clap, thumbs up. Oh, this is joy. Oh, Kunji, you got that. Thank you. K-Pool, okay, you got that. There's no angry face. Maybe this. Open mouth. Everything's good. K-Pool. Oh, K-Pool, you need help?
Oh, no, no, Professor. Sorry.
Your face.
I'm just joking. Bye.
I see. You got angry. I didn't get yet from, yeah, I'll wait. Oh, this is good. It's called the emotion, electronic motion. I believe it is called, right? Gianni, what is it called? Like this. Is it called electronic motion or emotion? Oh, there are others. Ah, there's an angry face. Oh, there's animals. Fruits. What is this? Lots of emotions possible. There's no bad things, right? I don't know why. Maybe this. Stuck out tongue. Stuck out tongue. Yum. Oh, Gianni, good. Thank you. You take time. It's okay. I want to make sure that you follow. Bilal, did you respond yet? Did I miss? Or you need more time?
Yes, everything's good, Professor.
Oh, what about Marcos?
I don't want to be silly on YouTube.
Oh, Marcos, are you there? Are you done?
Yeah, I'm here.
Are you done the exercise?
No, I'm still working on it.
Okay. I'll give you maybe 2 more minutes. Anything that I can help you over the phone? Over this verbally? What is the issue at your side right now? Marcos?
I wasn't having an issue. I was just finishing it up.
Oh. If you didn't start this, yeah, it takes time. I know. You need to download uh, the notebook on your laptop, and then you need to upload it. And yeah, it takes a little time. Other students, you can go ahead. Other additional exercises on your own, because there are many on uh, the Jupyter notebooks, so you can practice it, as you may know. Oh, use things. Requirement. I think we've done this. Okay. And then we'll do it. Okay, let's move on. At this point, I want you to think of the print statements. So let me ask you, these print statements here, remember that when we invoke a function, then we need to know the parameters, how many parameters that is required, or how many parameters that we can use. In this case, how many arguments that we send to the function definition of a print? How many arguments that we send? Bilal, how many parameters that we sent?
We sent 2 parameters. Hello, can you hear me?
Yeah, why?
So we can see point and the grading point. So the main print function has 2 brackets between the eastern 2, and then we are passing the 2 parameters in the format function.
Let's look at the help. built-in function print module built-in. This is print, and prints the values to a stream or to system.standard output by default. Separations, string inserted between values, default to a space. String inserted into a value, and the file, there's no, why this is so, what if I do print? It's not really good enough. What about the one that we looked at today? Where did we have that once? We tried to do something today, right? I'm looking at that once. Accidentally we used something. Not here. Where did we have that? Oh, here. Okay, this is, okay, here. This is print statements, right? How many parameters that we sent to the print function? Bilal, again?
I believe it's 2 parameters.
In this case,
It's
also
only one variable, the ftemp, but we give it to the print function as 2 parameters, 2 different ones. Oh no, here is 3, I believe. There is a variable string and the type ftemp.
That is correct.
So they are separated by the comma?
This is one value, this is another value, and this is another value. So
okay,
3 parameters sent to the print statements.
Okay.
What about
I thought the question was about what's the difference between the ftemp and the type ftemp. So these are the same variable, but the type,
right.
it's like
I'm talking about
different.
That for the print functions, not the function that we defined.
Okay.
In this case, to the print function, how many parameters that we sent to? In this case, 1 parameter only.
Yes.
The other, that is
because we use the dot
function.
Dot format.
One parameter that we sent. So went back
is the oriented object, the dot.
Right. Went back up. Yeah, oops, right here, right? This is 1 parameter sent.
There is only one.
Right.
Yes.
Same thing here, 1 parameter. And we looked at the previously, there are 3 parameters we sent. And sometimes we can do only 1 parameter. Like if I can make a print, there is nothing, and print, then I may say hello, and another print, I can say, and another one, print, right, all of these, then I can say this first print statements that it makes 1 space, 1 line. If I don't do anything but like this, then that gives it 1 line. That is similar to, no, I'll do that later. And this is hello, that is another ones, and there's a space, and 1, 2, 3, 4. So we have 4 parameters that goes into that function definitions, and 3 parameters goes into function definition. The one that I want to say here, if you consider print statements, remember that when we define a function, so that I want to receive one parameter, what? One parameter here. It says parameter PTS. One parameter only. Grading takes one parameter only. So if you see this function calls, then this grading function takes only one. It cannot take, for example, if you do 2 and 3, then it'll give you an error, right? It says grading takes one positional arguments, but you gave me 4. I gave you 4, right? One. This is 1, 2, 3, and 4. Clearly, this guy says 1 only. Then I can run it. However, so this is, you call the functions based on functions exactly as it was defined, that I said somewhere here. Said call the function exactly as it is defined, right? But I am confused because the function, I do not know how it is defined. But when I invoke it, I can invoke it flexibly, very, very flexibly. If I have a 1 value only, then I can call the print function with a 1 value. I have 100 values with me, I can do that, right? Very, very convenient. How it is possible? Probably it is defined that way, right? Is there some way that I can define it so that I can use it flexibly? Yes, it is. So I can go down a little further. By the way, there is a homework assignments you need to do. Homework 5.1, 5.2, and yeah, before we go for that, that is this. The one that I want to do finally for today is this star or double star. Remember that I made here Python 3 and then help and print. Then it says star args. There's a star, right? Star args. Right. Terminates. So before we get to that, multiple functions are possible. So function can, inside the function definition, we can invoke another functions. Def f1 function, from here, this is highlighted, there is one function definition, right? And the first statement in that function implementation, that is a print statements. And the second statement is print, but the result of a function call, F2. Which one that I want to print? That is that I want to print the value returning from the function invocation of F2. So before we do return, we need to call the function F2. So when you come here, function F2, then I need to print the first statement. It says a second function. So actually what happens if I call F1, then this first print statements is printed. And then the second statement here wants to print, but I have to first invoke F2. So I come here, F2, in order to complete to get the result from the F2 function, then I need to go into the return function. Before we get to return function, I have 3 additional the statements before that, right? So I have to print here 2 tabs and the second function called. So this will be the printed, and the second line printed is this function calls. In order to get to this return, I need to the second print statement in the function F2. That is, another invocation is needed. So before I complete this, I need to invocation of F3. So I have it here F3. Again, the first statement within that F3 is print statements. 3 tabs, and then I print third function called. So I print it, and then I return this. This is returned. So this string is returned. So when I come here, the caller of this F3 is here. So when I come here, whatever it is returned will be printed. So this triple tab and third func done, that should be written here. So second statement is done within F2. Then third statement is F4. Before we done this return, then we have to consider F4. So come here, F4. Then I said, first print statements, triple tap and fourth function done. And then this is returned and returned to the caller. Caller is here. So that is printed. And after that, then we need to complete F2 because we done first, second, and third print and return. Then 2 tab and the second func done. That string is returned to the caller. What is the caller of F2? Caller of F2 is here. So when I come here with that value, this guy says print it. So this guy prints backslash tab, and then second func done. That is done. And after that, return. 1 tab, first func done. Return to the caller. Where is the caller? F1 all the way down here. Caller is F1. So that is done. That is the end of that, right? So when I call this, it's done like this. First statement is first function called. When I call this, come here, I have to complete this function, right? Print. So first func called, that is written here. Before I do this, I have backslash t, which is a tab. So I have tab here. That much jumped to the first tab. And then inside this F1 implementation, that is a second statement, which invoke F2. So we come to F2. Then first statement is double tap and second function called. So I have here first and second tab and the second function called. So second function called. And after that, in order to complete F2, then I need to complete until done, right? So second statement is the print statement, which is to print the result of the function invocation of F3. So go to F3. Then first statement within F3 is third function called. So I have a third function called. When I done this, then it returns this string. That string back to the caller, and caller said print it. So that this third func done is printed. So third func done is printed. So this is done. And the next one is, again, print the result of the function called f4. So if you go to f4 here, then triple tap and the fourth function called. So triple tap 1, 2, 3, and the fourth function called, and so on and so forth, right? Okay. Each value can be received by a variable in a function. Multiple values can be received by a variable. In this case, a tuple format. This question, I want you to read it. And problem 5.3. This is very interesting. Kepler has some issues of connections coming back and forth. Okay, let me explain this. The problem 5.3. I want you to define two functions: get tax rate and check out. Considering the tax table below, when you buy some stuffs, then you need to pay tax, right? So we have city of New York City. We have this is the table. So considering two cities, New York City and White Plains. And New York City, if it is clothing, then 0%, no tax. If it is cheaper than $100 US, and over that, then 9% or 9%, which is anything else 9%. That is for New York Cities. White Plains, electronic 11. No, up to this. Okay. So everything here. So this guy is saying clothing, electronic, and others. That's for New York Cities. If it is clothing, then two types of tax plan. 0% if it is cheaper, 9% over 100. Electronic, doesn't matter, 11%. All others, 10%. That is for New York City. White Plains, electronic 10%, others 9%. So only electronic 10%, all others. Clothing, all others 9%. That is the tax tables right now, okay? So with that, what happens is, in your cart, shorts, which is clothing, $39.99 from New York City. Then tax rate is, there's no tax, only pay $39.99, right? TV, that is electronic, from White Plains. White Plains electronic charge 10% tax. So $999, that is the price, plus 10%. That is the price that you have to pay. Muffin, that is bread, $9.50 from New York City. When you come here in New York City, then muffin is others, that 10%, right? Jacket, that is a clothing from White Plains, $49.95. Clothing at White Plains, there is no special cases for the tax plan in White Plains, which is at others. So 9% applied to this value. And the coat bought in New York City, that is $239.55. So when we see New York City, then clothing, ask 100, ask 9% if 9% tax if it is over 100. This is over 100, so pay that once. So gives with that, so get the tax rate. I believe this is written. This is given, right? If you give me city and kind and price, then I can give you the tax rates. In New York City, clothing over 100, 9%, others 0%, electronic 11%, others 10%, and White Plains, if it is electronic, 10%, otherwise 9%. This is given, okay? Get tax rate. So this is given. We need to check out. In checkout, so given, you have to read this and then impose whatever the tax onto that calculation. So for example, shorts, $39.99, TV, $999 plus 99 tax. So the price that you need to pay is this. Shorts, because it is from the Manhattan, you don't need to pay, right? For example, jacket, I think it's you bought it White Plains, so you have to pay this. If you compare these shorts and jackets, both are clothing, but differently you have to pay depending upon the place that you purchase, right? So everything of this, and then you say, please pay the following. This is the amount that you have to pay, right? So you have to do get tax rate. You already have that. And then check out a little bit of codings here, right? That is homogeneous. Okay, now this is the final item that we have to deal with today. Variable length arguments. Variable length, that is possible. So 1 star or 2 stars. 1 star, there's a non-keyword arguments. Well, there's arbitrary number of arguments. And 2 stars, there's a keyword arguments. So if you see these two, if you compare these two, then you don't need to keyword for the star, 1 star. If you have 2 stars, then you have the keyword arguments, which is, what that means is that if you have a double star, then consider the dictionary formats. If you have single star, then arbitrary number of arguments. So for example, I want to make this separately here, copy and paste here. And I want to call the way that I can call, if I have this, I can call, oh yeah, it's very nice. I can call this, and I want to print, then do this. I can do more. Still, I can run it. Oh, comma, comma, comma. Right, 1480. So whichever that I want, right? If I want to have, for example, I want to first get the data. This is the way that I directly enter the raw value into, when I call, I use the raw values. That's fine. Just like when you print, then I made any number of parameters, right? But at the same time, I can define first something in for example, tuple, something in list, something in dictionary, what should I do? If it is the case, then I need to do here the definition. When I define, I need to put here star. Therefore, star and variable all together, one word. All together, one word. Okay? And when I use this variable, I use the variable itself, no star. In this signature, I use star. In my implementation, I use value itself. Okay? That is the way that I define. When I call that, I define the value in either list, tuple, or dictionary. And when I call it, I call with the parameter, here parameter, this is called the arguments, right? Anyway, these arguments with star, parameter with the star. Implementation, no. So in this case, it works too, right? 14. You can do something here, fine. 25, right? If you do this, so what happens? Print type of that, print type of that. That okay. If you want to see it print, you cannot, because there's no specific type with this star. So rather than that, if you want to do, hey, what is, if I want to print star that, if I want to print that only, see how they are different. See, if I do print that, then I would have the tuple as is, like this. When I do star that, then each raw values within that tuple, like this, 4, 2, 3, 5, 11, with this star. So when I call this, remember this, I wanted to see this call and that call. They are exactly the same ones, right? Add underscore all, I put the values, the raw values, which is the same effect here. Although I have values in tuple, list, or dictionary, with the star, look at this, the second bottom print statements, then it is just like 4, 2, 3, 5, 11. Instead of star dot, star that, it'll be 4, 2, 3, 5, 11. Just like I have here, right? That's what I want to explain to you. Look at that and think of it. If you have any question, let me know. Now you know in what case that you need to put star. This is exactly the same when you have this. right? This is the single star, which is arbitrary number of arguments, and the double star. Oops. Show profile. Look at this dictionary first, and then star info. I would get the star info. Show profile, and info dot items. Items means if I have this, then I'll give you step by step. Let's see. Okay. I think this is better. It's fine. Okay. Copy this. No, before I do, I need to copy this. If I do items, then it gives me this is key and value pairs, right? Key and value pairs can be formed in a tuple. So name, comma, John in tuple, major, comma, dot cybersecurity, campus, comma, dot NYC, something like that. That is what this item can do, okay? So when you have here info.items, then it gives you the tuple, right? So that you can receive this for loop. For loop, therefore, entire here, that is, look at this. That is a list, right? You can put here list. If you put here list, then you can see more clearly. This is a list. List of a tuples. List of tuples. So there are 3 tuples. Each tuple you have 2 values, which was originally key, which was originally value. So key and value pairs in a tuple. Those tuples are in a list. Remember, this is for loop in this list, but list is a tuple so that you can receive 2 values. So first one first, second one second. So first one is K, second one is V. So that you can say F equals V. Okay, that's fine. So this is the function definition, but you receive this as a star info. If you say info, then you cannot expect this kind of dictionary, right? But because you said star, now info is nothing but a dictionary. So that you can handle like this. That is the function definitions. And the way that you invoke, this is the invocation, right? So I want to define this first. This is So we want to invoke. So we don't need to do this. So we simply call, for example, show underscore profile, and then star profile. Okay, this is a dictionary. So I put there star and call it. Then it can say name equal John, major equals cybersecurity, campus equal NYC, that type of returns. Oh, so we want to see here F. Then we saw name equals John's, major equals cybersecurity, campus equals NYC. Either you can do this or you can do print K equal B. So first one is from this formats. Within one single quote, you have a placeholder. You name it. This is it. One string. In that format, there's equal sign. The two placeholders. Rather than having, if you don't do this, you can do like this format, and then K and B. You could do it like this, right? Or you can do simply here K and V. Don't need to do this. This is simple ways. Okay. Same thing here. If you want to do print profile and then print star profile. Here star profile, the name is invalid keyword. Yeah, you cannot do, you simply do, yeah. Star cannot print it out. So you can do like this. If you do print profile, then it'll be this printed. Forget about this calling. It's confused right now, right? We call only that. Two print segments. The first one is the dictionary as is. So this is dictionary form. If it says star profile, then it gives you the key only, but not in any container, but the value only. Like the one that we looked at here. Like that, then we have value only. If we have a star. But two stars, not available. Okay, so we call that. And I want to skip that. And the other way that you can call is, you can call it directly, whatever that is. You can call show, right? You can call it like this. Name equals John, major equals what, and campus equals that. This is still okay. So you can instead of making dictionary, you can put the raw data, say name Adam, major, computer science, campus NYC, still fine. I want to remove that also, like this. Okay, so I wanted to practice this. I'll give you 5 minutes. This is all I have prepared. The other one, format and join. This is something that you can see on your own. This card. And I want you to give me emotion if you are done. So I want you to practice this. So you can do what, single star for arbitrary number of parameters, double star, key and value pairs. Kunji,
Yes,
did you
Professor.
do? Did you try?
Yes,
Did you do that successfully? Do you need more time?
a little bit more time, yes.
Okay. Bilal, are you done? Do you have any question? Marcos? Gianni? Kapil? Gianni's done. Kunji's done. Marcos done. Kapil? Do you need help?
Is it okay, like, if I do it in a bit, Professor? Like, I'm not in my laptop at the moment.
Oh yeah,
But
yeah. You can
yeah.
do it. Yeah, on offline.
Thank you,
It's fine
Professor.
too. What
But
about
I'm still
Bilal?
trying on my phone.
Bilal, question?
No, sir. All good.
Are you good?
Yeah.
All right. I think this is it for today. So there is a little bit of other the exercises that you could do. Yeah. Okay. All right. I will stop for today's lecture here. Anybody has any any additional questions before we dismiss?
Yes, Professor. I just have a few questions on the midterm. Are we going to get a study guide for the midterm?
Kunji, I think you probably missed it. As I said, the next week we'll have the lecture, and then week after that, which is during spring break. So 2 weeks from today, the evening at 7 o'clock, we will have a review session over Zoom. If you can join me.
Okay, yes. Yeah, I probably missed it. I'm sorry. I joined a little bit late.
Okay.
Thank you, Professor. Thank you.
Any other?
Wait, what time did you say is it going to be?
7 p.m.
Okay. And you're going to send it through like Zoom or do you just.
I will invite you.
Okay, cool.
Yeah. Not 7 in the morning. Right, Gianni?
Bye, Professor. Have a good day.
Okay.
Thank you, Professor. Have a good
Bye.
day.
Goodbye, everyone.